This conference will now be recorded.
Yeah, thanks for reminding. I already started. Okay, so let me. So this is the VM, and you can see IP address here. So public IP address or public DNS. Just copy this. So either one will do. So one is an IP address which is accessible via internet, and this is DNS entry, and like 7180. So this is the port where Cloudera Manager is running. So if you're not getting the page immediately once you turn on the machine, so no problem. So it by default it takes some time to initialize this DB, and the complete startup of this Cloudera Manager will take a couple of minutes. And let's connect to that. And I already saved this. Just to hit the load, and but this IP has changed. I'm just adding the new IP and saving it and just opening, and type the username CentOS depending on the VM type. So your username may change. Just change settings, and I'm just increasing the font size a little bit, and color just using the system color, and sudo su. So this is a command which we use to switch to root user. So basically, either you can use this with the sudo and all the commands you can execute, or here I have option to switch to root user, so I can switch to root user. So root user is the administrator, and he can do everything. So let check. Okay, so instead of service, systemctl status Cloudera -scm -server. So this is the service. Okay, so Cloudera SCM server. So that is the service which is running on the Cloudera Manager host, and agent is also there. SCM, I think server-db is another service. Okay, so that is the default, and Cloudera-SCM daemons Cloudera. Just a second. List all. I think only these three services. Okay, so this is only package. Okay, that is fine. So we have seen like Cloudera SCM server and SCM agent and DB server DB. Okay, so these are the three services that should be running on a Cloudera Manager server host. If that is not running, something wrong with the service, you may need to start or restart the service. And this DB service, maybe if you look into a production Cloudera installation, you may not see this DB service, but in that case, they will do the database installation separately, and so that is the reason the service is not there. Since it's a default installation, that is there. So we and also there is one more way to check. Just use the telnet. So if you don't have the telnet, you can just install So this telnet command, then use telnet localhost. So since I am using the localhost, so this is the server where my Cloudera manager is running 7180. So this should connect. So you can see this escape character is something. So if you are getting a message like this, so that means uh, you are able to connect to this port and service is running here. Now definitely if you just come here and do a refresh, we should get this page, right? And default credential are admin. Okay, and so this is so here I can see, so both are showing in unknown state. So what I'm going to do is just trying to restart the service. Cloudera management service. I'm just restarting. I think that will resolve this issue. Since we kept this machine turned off and this is the first time we are just starting up, so that is why. Otherwise, it will always show either in green, amber, or red color. Okay, so while this is getting restarted, let's quickly refresh the topics that we have already covered. So we were doing a single node and we were using the default installation using installer. Okay, so Cloudera installer we were using. Okay, but this way of installation is not recommended for production type of deployment, but you can do that when you do a testing environment, or you can do when you do a trial or testing kind of environment. So this installation is and configuration is relatively simple and easy and straightforward. So what you have to do is just download one file, the Cloudera installer. So for that, we just okay, now this is okay. So we went to this website cm5. So archive.cloudera.com/cm5. Go to this location and you can see multiple directory here. So we just went to this installer. So I was telling like we used Cloudera manager installer, and choose any version which we were going to install, and you will get a file like this. Just copy that link, or you can save this link as and download this and transfer this file to the machine where you are going to do the installation. So once you transfer that, just use chmod plus x and add execute permission to this file and do execute. And there will be a series of steps, so that will go through each and every process, and based on this there will be a directory /var/log Cloudera manager server installer, and you can see each files are getting created based on each step. So first checking prerequisites and installing the repo, all those things it's doing, and finally it's starting uh, Cloudera manager server for each process that this script is doing. So it's generating different log files. So you can go through these log files if you feel like if you're seeing any error during the installation. So once this completed, this Cloudera manager installation is straightforward, and what we just used is like a chmod, just downloaded and added chmod plus x and this file, and file name, what is the file name, whatever the file name we have. So Cloudera manager installer bin, then just use /Cloudera manager installer bin, this file name, and this will do the installation. That's about the Cloudera manager installation. So Cloudera, it do everything. So Cloudera manager, agent, server, installation, configuration, everything. Cloudera manager installer will do that. So once this is done, you can open and log in, use the public IP, then 7180. So this is the port where Cloudera manager web UI is listening, and 7180, that is a default port. So until and unless you are not going to change, so this is remain same. So you need to open with 7180. So that is a port here I used. So once this is done, so we can go ahead and deploy the cluster using a parcel. Like I said, there are two options. CDH is like core Hadoop components, and for that we have parcel and package option. So package use like RPM or Debian package, but the recommended way is parcel. And it's all based on just multiple clicks. We can do the installation and deployment, and under CDH we can install whatever the components we need. So we have HDFS. Okay, so we have yarn. So yarn is a computational framework, and HDFS is a distributed file system, and we have zookeeper, etc. And we have some Cloudera management service also. Okay, so Cloudera manager service, and this is the CDH component, and it's Cloudera manager service. So we can install these components when whatever the components we need. And also there are a few things that we need to do before doing the installation that we call as prerequisites. So THP, transparent huge page, that we have to disable. SC Linux has to be disabled. If you need to check the firewall rules are proper, or worst case, we can turn it off. And also we were creating one user and adding sudo privilege, like a passwordless sudo. And we just created the key, public and private key pair, and use the private key, and that we kept outside, and that key we used in Cloudera Manager. And these are the things that we have done in the past 2-3 days. And I hope you already tried this. And if not tried, so just go through that recording once again, and just make a try. So you can easily deploy this single node, and this is just a basic thing. And also, like I said, so we have components like HDFS and yarn. HDFS stands for Hadoop Distributed File System. So before deploying, let's just see what is HDFS. Okay, so HDFS stands for Hadoop Distributed File System. So distributed file system means any file system. Like we have a NTFS file system, we have FAT file system, ext2 file system, and ext3, etc. So what are the file system? It's just an extraction layer. We have a disk, hard disk, and in operating system is making use of some file system by using this hard disk. Like we are using C drive, D drive, etc. Right? And then only we were able to do that. So these are some file system. So, but this is all operating on a single hard disk, or whatever the hard disk is associated with. But the distributed file system means any file system that is making use of multiple hard disks. So for example, there are a lot of distributed file system is there available. Lester, PVFS, and HDFS is a one among them. Like, so Hadoop distributed file system. And so how this file system work, and what are the various components for this HDFS? So one is name node. Okay, so just understand this terminology. Second is data node, and third is we have a secondary name node. Okay, and sometimes we have a standby. So standby is like if secondary is in case of standby, secondary is not needed. Okay, and these are the various components associated with the HDFS. So here in Cloudera Manager, so okay, for once you log in, you will get a page like this, and here you can just hit here and see what are the components associated with. So first page you will get a summary, like what is the capacity, so what about the health check, and what was the historical status, and on the right hand side you will have some chart. And if you go to the instance, here you can see the various components associated with. So you can see name node, and in bracket it's showing us active, and we have a secondary name node and a data node. Actually, the name node is a master component and the data node is a worker or slave component, and secondary name node is the node that helps this name node during some recovery operation and checkpoint. I will explain that. So what is the actual role of the secondary name node? First understand, so these are the various components associated with the HDFS and how this file system work. So that is again question. So like I said, so it work in a master slave or master worker pattern. So we have one master. Okay, so this is our master, and we call this master as name node. Okay, and we have multiple workers and so on. Okay, so these workers are called data node. Okay, so we have name node which we call as master. Okay, so name node is a master and data nodes are the worker host. And okay, so we have some networking component, and through which all the hosts are connected. So whatever the including master and all the data nodes. Actually, this name node so work as a metadata server. Then you may be thinking that what is metadata? So metadata means data about the data. Okay, so actually, like I said, so this is the master for this file system, and which take care of complete metadata, like where these files are stored. Okay, in simple case, so like we are storing a very big file, and we initially we are just instructing name node to store that file. So what name node do? So name node will split this file into multiple pieces. Okay, like one user is trying to upload one files to HDFS or to this file system. Okay, then HDFS name node or what, this file system will split whatever the input file into multiple pieces, and each piece will have a 128 MB minimum. Okay, 128 MB size. Like maybe you are thinking like if it's a 500, then what will be? Then 128, 128, 256, and what is remaining? 128, and then the last one is uh, uh, 116, I think. Right. So these many pieces, like if I'm just uploading 500 MB, so this will split into this many pieces, but last piece will have only 116 MB, remaining as 128 MB. So this piece is called block. Okay, block, and default block size is 128 MB. You may be thinking, what is 128 MB? So that is the default block size. So block is something like when you upload some files to HDFS, then that will be split into minimum this much pieces, and also this block size, how much size, again it's a configurable parameter, so that you can do here. Go to the configuration, just see block, see the HDFS block size 128 MB. So this you can increase or decrease, but most of the time, so in enterprise, they will use this 128 MB. Okay, so that is the block size. And how this is storing, again, that is a complex process. So like say for example, a user or process want to upload some files to HDFS. First, it will approach to the name node. So name node will have the list of nodes that is called data node, which actually store the data. And name node will there is an always heartbeat mechanism between name node and worker host, and name node will have the information about all the worker hosts. So what are the free space available, what is the status about the worker host, what are the blocks associated with, etc. Okay, so when we are trying to write this file into HDFS, and this will return, okay, where to write, then this application or program directly go and write that pieces to there. See, say for example, I have 1 TB, 1 TB. So the reason for using in a distributed way is, so we will get a, like a 1 plus 1 plus 1 plus 1 plus 1, like 4, right? So we can just make use of all these, and together we form whatever the data we have. So for example, if this is a 4 TB, but it will be split into multiple pieces, and each piece we can store into various machines. Okay, and I'll show you that in detail. 1 second. Okay, so we have a name node and we have a workers, right? So for example, I have a file. Okay, so this is just a logical representation. I'm just naming that block as A, B, C, D. Maybe this is 128, 5, 2, just a 512 MB, right? Also 128, 128, 128, 128. So just a 512 MB file I'm just trying to store into HDFS. Like HDFS, it's a networked file system. So what it will do, the name node will tell this application or process. Actually, this can be an application or process which is trying to upload files to HDFS. So this block, it will, a name node will have the information like what are the free data node and where to store all this algorithm. Name node will take care. So name node will have the complete metadata about this system. And the first piece, A, maybe it will find out, okay, so this is suitable for storing that. Then this application directly right here. So we have the block here. And one more thing it do, the same block, it will write into another machines also. Okay, so once this is written here, it will write to that blocks to here, and maybe another machine here. So we have multiple copies of the same blocks available on different hosts. So this is called replication. Okay, and how many replicas we need, that is controlled by the replication factor. So you may be thinking why we need these multiple copies. The reason is uh, we are like expecting any one of these hosts will go down at any time. So in that case, we will have the data available on other machines. So similarly, the B will also be stored here, like maybe here also, maybe here also, and C will be here, here also, maybe here also, and D here, here, maybe here. But we don't have much control on which node to store, but it's all controlled by Hadoop distributed file system. We will just use this HDFS, I mean, location where we want. So like for this 512 MB, maybe something like abc.txt. So this file, when I upload to HDFS, actually it's storing in to backend machine. So these are called data nodes. And this is name node. So name node will have all the metadata information. Like if I say abc.txt, what are the blocks associated with abc.txt? Like A, B, C, and D. These are the blocks. And what are the, how many copies are there for this one, and where these are located? All this information. So this information is called metadata. And this information, it's stored in name nodes memory. Okay, for faster access, it store this information in name node memory, and The problem is if our name node goes down, so this will go away, that whatever the data available in its memory. So that metadata it's storing in its RAM, not onto the hard disk. And if I want to access this one, okay, it will have that metadata information. If I do a read request, so abc.txt, that is composed of all these files, and based on the proximity and the speed, it will choose the list of hosts. See here, suppose if this goes down, still we have the data like abc.txt. We can just use like so one or two machine, right? So we have a C and D here, B from here also. Like so, we have again the backup copy if one of these goes down. So this is called the replication factor. Replication factor means the same block we will be storing it into multiple data node. So that also we can just search here, go to the configuration, replication. You can see that DFS dot replication. So this is the parameter replication factor. So that is 3 by default. That means when you upload something, the same block will be stored into 3 different worker hosts. But the problem here is we have only one node at this time, but don't compare our scenario with this host setup. Here only one host we have. So that is the reason we have only one data node available. But if we have multiple data node, so if I upload something, that data will be split into different blocks, and each blocks will have, availability on 3 different minimum. Again, it's a configurable value, so we can increase or decrease this one. Uh, okay, that is about the replication factor. Then block size, that is a minimum piece. Block size of the piece, and the replication factor is how many replicas we need. And name node will have, like I said, name node will have all the information in its RAM or memory. But however, certain period of time, so name node will store that in-memory metadata into some file. Okay, so this process is called checkpointing. If you're not able to understand the first time, so no, don't worry. So, but initially it's very hard to digest, I know, but just try to understand. Okay, so this is the name node, and the data nodes are available for HDFS. Name node is a master one, and data node is a worker one. So name node will have all the metadata information in its RAM. So reason for keeping the RAM is, so if you keep that information in RAM, it will be much faster when we try to access a file, or metadata access will be much faster, because we all know the RAM is much faster than hard disk. But only challenge is if this goes down, then again the next time if we reboot that the same memory image won't be there. So we need to save it somewhere, and this saving process is called checkpointing. So whatever the content in memory, so that will be, only the metadata, not the complete memory image. So only the metadata of this HDFS will be stored into a file called, this is called checkpointing. And so this file we call as FS image. Okay, so FS image is a file which is created as part of checkpointing. So that is nothing but HDFS metadata that is saved into a file. So you can see that file, and here, so we just need to find out where we have this HDFS name node files. Okay, so go to the configuration, and left hand side we have a couple of filter option available. So the first is the scope, second is the category, third is the status. So we will check the scope. Scope is just filtering based on the roles. Like, so what is the role? So we need to choose the name node. We are just trying to find out where these FS image files are getting stored. Just hit that, and you can see immediately, you can see this one, name node directory. So name node directory is the directory where our name node will keep all its files. So we have a FS image and all those files available in that location. So we will go to this host, and that is in the name node host. Go to the directory, and you can see the current, and there will be multiple files available. So under current, you can see an FS image. Just type lslrt and see. So maybe multiple FS image will be there. So I think in our case, uh, so the one which is created on January 6th, and one is today's date. So this FS image will be created whenever the name node or HDFS service start, or every 1 million transaction happen, or every 1 hour. So this is automatically happen. So every 1 hour, so the name image will be saved into this into different file, or every 1 million transaction, or whenever we restart the service. So this is called FS image file. Okay. So and one more file is there, edits. Apart from FS image, so whatever the, it's like if the people who are from the Oracle background might be knowing edit log file. So similar to this. Okay, so here we have edits. So edits means, so once you have taken, yeah, like checkpoint means, like I said, checkpoint is something like it's taking the backup of a name node metadata into a file, and that file will be with the name. So we call that file as FS image. So that will be under the default directory of this name node, and under current you can see that FS image. So like I said, it will be I mean, it will take this FS image based on the configurable parameter, but the default is checkpoint interval is every 1 hour or every 1 million transaction. And that is also we can get from here. Go to the configuration, just check with the checkpoint. Yeah, well, trash checkpoint interval 1 hour. Okay, and somewhere we have that checkpoint. Okay, let me clear this filter. Okay, first to trash checkpoint, and yeah, so this is the yeah, these two parameter. Okay, so file system checkpoint transaction threshold, I think it's a 1 million, and so this is the time 1 hour. So this is again a configurable parameter, so we can increase or decrease, but most of the time, so we will go ahead with the default. So this time period, like a file system checkpoint uh, threshold and file system checkpoint period. So these two parameters are configurable. So this control when to take this checkpoint. So checkpoint is nothing but whatever the memory image of this name node or metadata or HDFS metadata. So that will be stored into a file. So that file you can physically see. And why it's storing periodically means whenever there is something happen or crash, the machine is getting crashed, or when we reboot the machine, so we can start this HDFS service from this saved FS image. And apart from that, okay, like I said, so every 1 hour only it will take, like so this is 1 o'clock, and this is 2 o'clock, 3 o'clock, 4 o'clock, or every 1 million transaction. But okay, once we have taken the FS image now, so we will have some lot of transaction happen this time. Then what if our machine shut down at this time, or what if my machine crash this time? So I have this FS image, but this is the image at 1 o'clock, right? But what if happen if I 145 or 155? then I will lose this data. But in order to track this, or we will write, or this name node will write that into a file, and that is called edit. Okay, edit. So you might you have learned two terminology, fs image and edit. So fs image is nothing but the checkpointing into a file, and edit is nothing but like similar to redo log or edit logs in any other tools. So whatever the transaction after taking this fs image, so whatever the transaction happened post to that will be recorded into a file. So if you go to the name node, the same directory, you can see other files like edits in progress, fs image and all. So this is nothing but the like, so another thing is it's not in human readable format. So only this HDFS service can read. So what will happen when we reboot our system? So it will load the image from the latest FS image. Okay, from the latest image, FS image will be loaded into memory, and then it will apply whatever the recorded, I mean, changes in the edit file to that memory, so that we will get a latest in memory image. So that is how it's handling this part, as it's storing in all this metadata information in memory. So just to understand this thing, but the later we will cover this checkpoint and other operation in detail. Don't get confused now. So just we were just introduce this Hadoop distributed file system. So distributed means it will make use of multiple servers, and it has got various components. So one is the name node, and we have a data node. Okay, so name node is a master, so there will be a one big server which is having higher end RAM. Okay, while designing the cluster, the people will ask, okay, so one server or two server with a very good RAM. The reason is it is storing the metadata information in RAM, so we need to have a very reliable machine with a high-end configuration, especially high RAM, because all the metadata information, if your files or if your HDFS size increases, definitely there will be a increase in usage of your metadata that is used for storing, that is in memory or RAM. I use the term memory for RAM, so not for the hard disk. So we have the multiple worker host, and that is having associated with the hard disk. Okay, so this is the hard disk, and we are using that hard disk for storing actual data. Okay, and this name node will just store all the metadata information, what are the data nodes, what are the associated disk, and what are the blocks. So whenever we are try to upload the file to not only us, like we in the sense, it can be an application, it can be a process, or it can be any program or anything. So that try to upload this file into HDFS, then HDFS system itself will split. Okay, you may be thinking, okay, so how do I split this into multiple pieces, etc. But that is not our job. So we will just upload the file, but the system will take care of that. Whatever the size of your input, so that will be split into multiple pieces, and each piece with 128 MB size, and this is called the block. Okay, so HDFS block, the default block size is 128 MB. And 128 MB and one piece. The same pieces will be stored into multiple servers. The reason is for availability. Even if some of the machine goes down, still we have data available. And since it's storing all the metadata information, its memory. So if the system crashes, definitely there will be a challenge. So in order to handle that, so every 1 hour or every 1 million transaction. So these two parameters are configurable, and based on that it will save this in-memory content into a file that is called fs image. Okay, and uh, also, like I said, fs taking the fs image is during limited period, like every 1 hour or every 1 million transaction, but in between it will write whatever the transaction that is happening in HDFS. Transaction in the sense adding a file, removing a file, copying a file, moving a file, any type of file changes that will be recorded into a file called edit. So this FS image and edits will be safe and secure and will be stored into different location. And also we can specify this to store into multiple location, especially one with the local and one with the mm, uh, I mean NFS or some shared location, so that even in case of this machine goes down, still we have this file. And actually we need this name node metadata, latest metadata information. For that we can use FS image and update this edit so that we will get the latest one. And there is always a communication between this name node and worker host, this heartbeat mechanism, and it's using the various port and IP address of this name node for that. So each worker host will be sending a report like block report and health of all those things. Everything is monitored by name node. So that's only the reason it's having the latest metadata information. So that's just an overview about the HDFS. We will see more details when we go through this. So before going to next, we will see any questions we have. So okay, so is there any middleware service which talks between a name node and a data node? Okay, between the name node and data node, there is no third party or any other tools, but this itself will, name node itself will take care of that. And also the data node will be keep sending this report, like we call it as block report. So that is also will happen periodically. And also the name node will have the complete details about this worker host, like so what is the availability, what are the blocks associated with, etc. So any other questions, you can make use of this chat, or you can also talk also, no problem.
Yes, I have a few questions. Uh, do we change the block size and replication factor in production anytime?
No, I haven't seen that. Like, so most of the production environment, it's using the default one, like a 128 and uh, 3. Okay, 128 MB is the actually that is the on an average and the recommended value from these vendors. So I haven't seen like people are changed, but technically we can change, but it's using 128 and 3 as a replication factor. So this is the block size and the replication factor.
Okay. Uh, One more thing is like how many data node failures we can tolerate. Like you said replication factor is 3, right?
Hmm.
So if one fail, we have two data nodes. Say, but we said like replication factor is 3. So do we need to add another data node, or it will copy that uh, meta block to another data node which is having free size?
No, like if we specify the block size as 3, our name node will make sure like so we have 3 copies available, and that is again a complex algorithm in backend. It's all consider okay on which rack this machine belongs to, and what is the I mean the data node, etc. So it makes sure like this block is available. Otherwise, it will synchronize that. So it's all based on like so we have a okay, so say for example if you have a three host, right? So we can handle the failure. I think if you have three and three or four, okay, four in the sense. Mm, uh, I don't know exact count how to say that. If it's three means definitely two we can, but in unfortunately, if we okay, say for example, my blocks are associated with only these three VMs, and if these three VMs goes down, then definitely I don't have any options, right? But that is very rare chance. So I think that is the reason mainly people use this replication factor as 3. And also, unlike other, maybe in case of any other data, like that we use in a relational DB. So for these people, data they will have, okay. So with these three, they were able to do this availability. I haven't seen like people increase these values, but technically we can increase by going here. Like, so we can just go to the configuration, just use the replication, and we can just use DFS dot replication, and this one increase or decrease.
This is Prashant.
Thank
So
you. One more
this,
question, sir. Srijesh.
Yeah, yeah.
Like, do we change the location of the metadata, or it will be default to NN?
No, we don't have any control once we installed and started, so that will be in its location. But during the installation, we can change that parameters. Okay, so I think I have not changed that, but during the installation, so we can add multiple location also, so that it will be added there. So this is like normally people do at the time of installation, and like I said, we can have the multiple location added here. Similarly, for worker host also, that directory we can add it into a different location.
Okay. And the checkpoint interval, do we change it in the production, or it will default to like 1 million transaction or 1 hour?
That is also we will keep it as a default.
Okay. Okay. Thank you.
So any other question? I think someone else also.
yeah, sorry, I was asking something. So, but I forgot now what I was asking.
No problem.
The chap was injecting lot many questions, so I think anyway, carry on.
Okay, like I think in that case, you people can use the chat window also. Whenever you feel something, like just leave it there. So I will check that so when we do a break in between these sessions. Okay. So when we move from one topic to another, so definitely we will do a logical break and we'll clarify those things. Okay, no problem. So any other questions and all? I think, yeah, right. I think all of you got just a peripheral understanding. So what is HDFS? So like here, so let me log into HDFS user. Okay, so this is the super user for HDFS. Like here we have root user in Unix. One second. Like we have root user, so which is having super user privilege. So like in HDFS is a super user. So this user is having super user privilege, and like we can just create HDFS, DFS. So for accessing HDFS, there are multiple ways. So one is from the command line, just use HDFS, then DFS. So earlier we use HadoopFS. You can use the same that also, but better use this HDFS. So if you use Hadoop, then you have to use like HadoopFS, and that is both are same. But I always use HDFS, DFS. So if you don't know about these commands, so there are multiple commands that you can use for interacting with HDFS. So that is HDFS, DFS. And if you don't remember that, just type HDFS, DFS, you will get all these options. Okay, and append to a file, cat, checksum, chgroup. A lot of commands are there, so we will see all these commands later in detail. So now I'm just using some command to create a directory. So hdfs dfs -ls. So ls is for listing the directory, then just use slash. So under slash So what are the directory? Actually, don't confuse it with our Linux ls slash. So if you type ls slash, so this is the Linux directory. So under Linux directory, we have this one, but this is a separate file system. Actually, this is the logical file system that is making use of multiple computers and storing it in its backend data nodes. And you can use this command to see what are the content, but actual data is making use of this folder, like I told you, right? So we have 1 second, I'll show you where these blocks are storing. I think slash, okay, the block storage location, just go to this HDFS. So instance, you will get what are the services, and go to the configuration, then go to the data node. So this is a filter. Okay, you can clear the filter, add the filter, and this is the data node directory /dfs dn, and we go to this directory. I was telling about the I mean the blocks and all in different cases, right? So just go to this directory and just go to the current and just go to the finalized. Then again there will be a lot of subdirectories inside that, so don't worry. So keep on go inside until you see. So nothing is here, right? So I think it's not having any files available in HDFS. That is the reason. So it's not showing us block. So, but let's try to add some blocks here. Okay. So this is the command I use for listing HDFS content, and you may be confusing like, okay, so this is the similar to the Unix file system. Yes, this is similar to the Unix file system, but actual data is storing somewhere else. So this directory name, permission, etc., is stored in name node, but actual data, if you have, I mean, any file, then that only will be stored in data node location. So what I'm going to do is I'm just going to create another directory that I can use, HDFS DFS -mkdir /user, okay, not USR. So all users home directory will be here. Just I can just use CentOS, whatever it may be. I'm just creating a directory like this. Okay, so this is not a Unix directory. This is HDFS directory, and I'm just writing a file. Okay, so vi test1.txt. In Unix, I'm just writing one file. Hello world. Okay, so save that file. Okay, so just created one text file inside my Unix file system. I just need to upload this into HDFS. I can use HDFS DFS -put this file name. So there are various command options. One is a put, we can just use for uploading. So this one to this location, right? Right. So now I have uploaded one file. So you can make use of this command HDFS DFS -put. So you can see that put option somewhere here. So the local source and then HDFS destination. So this is the HDFS location. This is the local file. And now if you go to this location here under data node, you can see something like block. Okay. So this is the actual data, and this is the metadata information, and this is stored inside one directory. Actually, this is the directory and under different subdirectory. So this is called block. So, but in our case, if I just use du-sch and check the size, so it's 4 KB only. But you may be thinking, okay, so this is not 128 MB. The reason is my file which I uploaded is very small, which is not having more than 128. So if it's more than 128 MB, so that will be split into different pieces. And also you have one file, right? So that is under /user CentOS, then test1.txt. So HDFS DFS -ls under this directory. it will list that file. Okay, and also HDFS DFS-cat also we can do. So that will read the content which is available in HDFS. And let's just check is there any bigger file available. Slash user java du-ssh src.zip. No, it's nothing is there with okay, so opt Cloudera parcels. Maybe this file is having very big size, right? du-sch. Oh, this is also 80 KB. Then okay, let me -sch. Okay, what I'm just doing is cp-rf jars, sorry, /tmp. Okay, I'm just copying this jar, but what I need is I just need a very big file which is more than 128 MB size. And but this is the directory, so I'm just changing this, zipping it into a simple file with a huge in size. Okay, so now let me go to /tmp tar. I'm just zipping this folder and making a big file. So one tar.gz file, and we will make use of this file and upload this into HDFS. Okay, let me copy this jar.tgz to okay. Okay, so we will just check what is the size /tmp. Oh, it's a very huge size. Okay, what I need is I need a file, not a directory, which is huge in size, and I just wanted to show you how these files are located in actual HDFS data node. Okay, so if you go to the current, and under current we have BP, and again current, there will be a lot of finalized and a lot of subdirectories, and you can see. So this is available block that is for only one, but this time we are trying to upload a very big file, HDFS DFS -put /tmp jars.tgz /user /centos, any directory, and that's it. So this is uploading the file. So this is a big file into this location. And at the same time, if you just keep on refresh, so earlier these two files. So that one with the dot meta is actually the metadata for that. So you can see till here is same, but only some appended with the dot meta and some values. That is not the actual files. So this is the block. So apart from 8855, so if you check other blocks, so if we will see lslrt, so this block, if you check du-sch, you can see it's with 128 MB. So this one also will be with 128 MB. Sorry, du-sch. You may be thinking, what is this directory? So this directory is actual data nodes location. So this is the data node location. Under that, there will be different subdirectories, and finally you will reach a directory where it's storing all the blocks. So under this, the subdirectory, there will be different subdirectories created when the number of file exceeds. And you can see two files. One is actual block and metadata file associated with that block. So that will be for each block number, there will be a meta file, and each file is with 128 MB. And we just uploaded around 1.3 gig. Maybe if we check the last block, that may not be with 128 MB, I think. Yeah, that is 92 MB. So all other blocks will be with 128 MB, because while splitting, the last piece definitely will be maybe less than 128, or maybe in ideal case it may be 128, but no problem. But it will use only that much space if that is leaking. So but since we have only one machine, so these blocks are not reported into different machines. So we have only single server available. So any questions?
Can I ask a small question? I think.
Yeah.
So the HDFS location, which you showed us on on the portal, on the console, which says some DFS/NN. Does that location need to be on data node only, or do we need to have that location on admin node, master node as well?
No, this is actually only on data node. It's okay. So data node is intended for storing actual data, and that will be only on data node.
It's not
So
necessarily that it has to be there on master.
no, but the reason is we are having everything in the single node, but this is not an ideal combination, but it's just a testing environment. Otherwise, so we have a name node directory only on the name node, and we have data node directory only on the data node. But in our case, it's just a mix of all these services. So that is the reason it's having these two together. But when we do that in a multi-node installation, so this will be only on data node or worker host. So we have a dedicated host associated with this. Only on that host, this directory will be there. Also, the files will be moved to that directory alone.
Right. And on the same topic, can you go back to the console? Can you add more than one location? I think. Can you?
This one?
Can you go back to the console, the Cloudera console?
Oh, okay. Cloudera manager. Yes. This one you're talking, right?
Yeah, I'm talking about the plus sign here on the. Okay, so you can do comma and you can add more locations.
Yes, I think here basically it's doing comma, but you can add more. Like I said, we have an option to add multiple location for. So we have seen two type of directories, right? One is the name node directory, where name node is storing all the FS image and edit files. Okay, so let me write it here so that. Okay, so we have seen two types of directory. One is name node directory. It was something like /dfs nn, and data node directory. It's something like /dfs dn. Right. So these two directories we have seen. Like, so this is the default one. Uh, I think so /dfsdn and /dfsnn. So this is the default location, but I have not added or removed or modified anything on this. And the another thing is, like I said, so name node, it store fs image and edit. So these files are very, very important in case of recovery. So we are using that in single one of the name node and in its directory, right? So the problem is, if this machine goes down, we will lose this file also. Then we won't have any other option to recover. But still we have a secondary name node available. So in that case, what we do, so we can have multiple location. Like I said, so either comma separated, or with the Cloudera Manager console, we can write that. So in that case, okay, uh, so okay, so this is our name node. So one is in name node itself. Okay, so this is just a disk location, right? Or just a say for example /dfs nn, and we can have one more on NFS shared, like okay, so it's like a /NFS nn, or it's something like a different disk, like /disk2/nn. So so here in name node case, 1 second. And so in this case, like I said, we can have add multiple. Okay, like /NFS/NN. So /disk2/NN. So if you write multiple location like this, so these files, when it create fs or edit file, so that will be same time will be written into all these location. Okay, so it's a synchronous write. So if you have multiple location configured, so you have this file, like mainly we were focusing on these two files, edit and fs image. So these are very important file in case of recovery. So we can make use of this file and reconstruct our HDFS if this goes down. Say for example, if this goes down, definitely this file system also goes down, right? So we have another option from NFS or other disk we would be able to recover. Or suppose if this disk alone goes down, still we have available. So if you write multiple location for name node, it will write at the same time in a synchronous way. So whatever the data available on one will be, the same will be updated or available on the remaining location. So that is what we can do here. So if you write multiple location, it will write over there. So in a production,
Okay.
it's always recommended to use multiple location. So one locally, one NFS, one in other file system, or one in other hard disk, because we may have multiple hard disk and different partitions associated with each hard disk. So we use that different location. So if you use this different location for name node directory, so the writing will be in a synchronous way, so that we will have the same copy available on all these three. Okay, but this is the default setting. I have not edited anything over here, so that is the reason you can see only one. But the same way, if you go to the data node, so that also support multiple location in a same host. Okay, so the reason is you may have multiple hard disk associated with. Okay, so this is one data node, another data node. So here you have it, 2 or 3 hard disk for HDFS, right? And that may be mounted to data 01 and data 02 or slash data 03, and here also slash data 01, data 03, like that. So if you write like that, say for example, slash data 01 dn, and this way if I write 1, 2, and 3, okay, it will not write in a synchronous way, but it write in a round robin fashion. Okay, so that is for data node, because we need not to do a multiple copy in the same node. This will happen to on a single data node. In a single data node, it's expecting, so these four directories. One is slash dfsdn, slash data 01, data 2, and data 3. So maybe when it try to copy the file, sometimes the block will be stored here. The next time block will be distributed here. Next time block will be, so that each and every hard disk or partition will have equally distributed. And it's expecting the same location across all data nodes. You got the difference, right? I feel.
Yeah.
So the difference
I
between
understand.
name node and data node location. Name node location means the same file will be replicated into that different location, but here it will write in a round robin fashion. And okay, so there is another question from Pavan. Remaining space of 36 MB occupy after file size, or the space will be waste? No, actually there is no wastage. See, if you want to store a 1.3 gig file, so it's using actually in backend 1.3 gig only. If the last one is not using, like, so maybe is confusion is here, like, so here the last piece is using 92 MB. So maybe thinking why it's not using 128. Actually, if we use 128 MB for the storage, so we have the waste of other remaining 36, right? But here it's saving that space. So if it's not needed, so it's not using. So definitely whatever the remaining space, actually it's storing in this Linux location. Okay. So the storage capacity is based on this partition size. Okay, how much it can store. So if we reduce 92 MB, which is storing here, definitely that 36 MB we can make use of a other file system, other blocks. Definitely, I want to say. We will just take a 5 minutes break. I'll have some water and come back.
you still on the call?
Yeah,
Hi,
can
Praveen.
you hear me? Yeah, hi.
Oh, sorry. Yeah, good.
Okay, yeah. Okay, so now we will post this HDFS part aside and we will continue later. But now we will quickly install Active Directory server, because most of the time in most of the enterprise we use Active Directory for a centralized authentication. Okay, so AD or Active Directory. So it's nothing but a,
Just before you install the Active Directory, I've just got a question about the data node that you've been talking about.
huh,
If we say that data node have one location, now the data node, or you say HDFS, is being utilized by many of the services that we have in Hadoop architecture, I would say. So even Hive is going to use it, Yarn is going to use it, or any other services you say is going to use the HDFS services. So now if in case the Hive requires a little customization with the data that is stored at HDFS, do we maintain a different directory, or we still go with the dfs.nn or whatever directory by default we have for HDFS?
no, actually, to answer that question, it's in backend directory structure. See, this application don't have any control. I mean to say the block where to locate this block. So admin has that control, but so that is just like a so where to configurable. But for each and every application, so we will create a separated directory structure like that. So like in Unix we create, right, HDFS DFS hyphen mkdir slash user abc1. Like this we can create different directories. So similarly, Hive or any other service that is also making use of this directory, but actual data may be stored into actual data, in the sense in the Unix level it's stored inside this worker host or data node location, but in HDFS definitely it's in a separate location. Like I have a CentOS, this is one directory in HDFS, but this is another directory. But if I upload something here, so that will actually stored in this physical location, in this location in our hard disk. So does this answer to your question?
I'm a little confused. Sujesh, no, what I mean is when you're trying to customize or you're trying to install Hive, I'm pretty sure that you give a location and you say Hive, this is where you need to take the files from HDFS, and then we install Impala. We say Impala, this is where you need to take the files from HDFS. So what I mean to say is all these services, Yarn, HDFS, Impala, Kudu, whatever comes in onto the Hadoop, do we maintain the same file structure, the default file structure, or do we give them a different file structure? Because Hive might require a little customized way the data is in Hadoop, or Impala does not require any customization. It will use the direct warehouse that we have in HDFS. So my question is, do we customize something from the data? Do we maintain a different directory for all these services, or we use the same default directory that is being created for HDFS for all these services?
To answer your question, in the Unix level, like that we were talking about slash dfsdn. So this is the Unix location. So that is same for everything. So whatever the services or whatever the components it's making use of. So because they don't have a, I mean, technically all the admin will have the direct access and go there, but on top we have one layer on HDFS. So here we have different directories like slash user or slash ap or slash xyz, etc. So we do the customization here, like slash user Hive warehouse for Hive. So this is for another application, etc. But in backend, it's all sharing the same set of location. So this is the location. Actual data is stored in Unix. So that is same for all the applications. I mean, so this is the location where the blocks are stored.
Okay, makes sense. So we actually don't do any customization. It will be taking it from the default location. Okay, makes sense.
Correct. Customization in the sense we do when we add a new hard disk. Okay, so we need one more location for this data node, or if we do some extra or replace the hard disk, then that time only we do the customization, but that may not affect this layer. And we have a Hive, Kudo, or whatever the service, which is again working on top of this HDFS. So we have the Linux, and under that we have a physical hard disk, right? So this is just a logical way of representation. Like we have a physical hard disk, and we have operating system and a Linux file system, and HDFS is working on top of that Linux file system, and we have various components which is accessing HDFS. So this way only this work.
Sure, makes
Okay.
sense. Thank you.
Okay, right, no problem. Okay, so we will have to because if you look into an enterprise, so all the user management is done through Active Directory. Okay, so similarly in Hadoop also, uh, it's a most of the enterprise you can see it's a closely integrated with the Active Directory. So before going further, like, so let me tell you what is Active Directory. So it's just an LDAP implementation, and this is the product from Microsoft. And LDAP, lightweight directory access protocol. So you may all know this, what LDAP means. So it's nothing but a directory service, or in simple word, we can say one user and its properties. So definitely the password is one property, and there are n number of properties we can associate it with a user. In simple case, like if you onboard a new company, okay, so they will give you one ID, and definitely one password will be there. Along with that, there are a lot of information like your manager ID, your mobile number, your desk location, this one, your intercom number, VNet details, etc., etc. Lot of properties we have to set. So all these things is making use of Active Directory. So in Active Directory, but we are just focusing only the username and password, like just a simple authentication thing here. And we have open source implementation like OpenLDAP, but that is very rare in enterprise. So mostly we use Active Directory for authentication. Like we will onboard the user here, and we use the same username and password across all the various Hadoop components. And we will be integrating various Hadoop components so that it's like a same username and password we can use across various components. Like if you join a company, so you have some user ID and password, we use the same user ID and password for logging to your desktop, or logging to your email, to your intranet, your VPN, or whatever the service they provide. So you may use the same user ID and password. So that is the reason, the reason behind that is, so all those components you are using is integrated with the Active Directory. So this installation and configuration is very simple and straightforward. So it's just within few click you can build a Active Directory server for your testing purpose. Now we will see how to install an Active Directory server, and then we will see how to integrate with our Linux boxes first. Okay. So for that, we will. So this Active Directory you can install with the Windows Server package. Okay, you need to have a Windows Server. So we will go with the implementation first. So go to this one, and you can see I already have an AD server. Let me check what operating system. VM ID, I think instance ID. Yeah. I'm going to launch a new instance. Launch instance and go to community AMI. I don't know. Wait, this is okay. I'll search with the Windows Server 2012. You can see a lot of images and choose anyone. So I'm just choosing this one. I think 64-bit base. Select this, and we are not going to do higher end much configuration here. Just AD alone. I think 2 with the 4 gig is okay. So configure instance details, just a 1, and make sure you choose the same. So can you guys hear me? I'm just hearing some, I mean, seeing some
Yes.
network.
Yes. Yes.
Okay, right. Because I think some slow network alert I'm getting. So in case if you are not able to hear me, just I mean, if the voice is breaking or something, so please let me know. So you can use the chat or uh, voice also. Okay, so here I'm just using the same network and VNet subnet. The reason is I should be able to communicate with these servers, and the remaining things I'm just using the default. So I'm not doing much customization here. Adding storage. So I think 30 is fine, but let's do it 40, and delete on termination, and adding tag. So you can add tag. I'm just using honor. Then network security group. So I already have some network security group created. Training Cloudera. So it's again completely open access, but it's not a good. So review and launch, then launch, and use the same key. So if I already created the key, so training Cloudera, then hit OK and launch instance. View instance. Just adding this name. Okay, so we will try to connect here, and for getting the password, I think it's not ready yet. Connect, get the path. So this is still showing in initializing phase. Okay, so now this is okay. For connecting this, just select that machine and hit connect. And for getting the password, so we have to choose that PEM file, whatever the file we have created. Go to the desktop and Cloudera training, and so training PEM file. This file has to choose, not PPK file, just to decrypt. So you will get a password, and you save the password somewhere here, and so you can just use this remote, download this remote desktop file, or you can use MSDSC and choose that option from here. Just hit that and use connect and administrator, and this is the password. So we have noted down the password somewhere else. Yes, click OK. Then yes. I don't know why. Let me close this and reconnect again. Okay. So open the server manager. So a few things we need to okay, the connection is lost. So can you all see my desktop and hear me properly? Hello?
Yes, yes.
Okay, fine. Uh, right. So I just connected to this VM, and I think somewhere we need to. Okay, I'm just changing the computer name also, but that is not needed. But still, we can that we can do later. Files and storage. I don't know, local server. Just go ahead and uh, turn on or off option. Okay, so that I just selected this Windows Server Manager from here, and you have dashboard and local server. Just go to the local server, and here Windows Firewall, just public on, just hit that and turn on or off. So I'm just turning off this firewall, but I don't have much understanding on the configuration of firewall on Windows, so that is the reason I'm turning off. So if you have any Windows server expert, so you can just uh, talk to him and understand, okay, so how to pass certain port and configure that. So but for our testing purpose, this is more than enough just to turn it off. And I'm just changing this server name, and just change AD server, right? Just OK. Then okay, so let me restart the server anyway. So only two things I did. So one is change that server name or host name. Then the second is the local firewall I just turned off. And that we can do from the server manager. And second option, local server, just hit there and do those changes. So once this is done, then we should be able to reconnect. So maybe this is getting rebooted. So we will just refresh and wait few minutes, then I can reconnect. Get password, then decrypt the password, then remote connection. Just use the password, whatever the password you used, then don't. So we use the same server manager here. Just hit here and just use this option, add roles and features. Okay, click here and just hit next. Choose the default role based or feature based. Yes, select that and next. So this is also choosing the default, hit next. Then so we are going to do two type of services, Active Directory domain services and Active Directory certificate service. So if I just do Active Directory domain service, so it will install only LDAP. So if I do Active Directory certificate service also, then it will install, it will configure LDAP S that we can do. So that first we will go ahead with the domain service. So later we will do this certificate service. Like when we do Kerberos enabling, so definitely it's needed. So we will have to do that. But at this time, so we can just go ahead with the domain services. Just hit next. Then choose the default one and then next, restart. Once this is completed, go ahead and hit yes, then install. So this is starting the installation. So basically it's in doing an Active Directory or LDAP instance here, and from other host, like maybe if it is our Unix server or Linux servers, Solaris server or any other server, or a Hadoop components like a Hue or Cloudera manager or any components in the Hadoop. So we can integrate that with this Active Directory if we need a centralized authentication. Like, so we should be able to make use of the same credentials that we create here. So from Venki, so in prod we don't this. Okay, the question was not clear. So can you elaborate that question, Venki, please? So in prod, so in production environment, I think I'm thinking it's in context of this Active Directory. So in production environment, there will be a separate team. So it's a very big team who is taking care of this Active Directory services. And what they will give, so they will just give you one portion, like we call it as organization unit, and we will give some username and password. So with that username and password, we will integrate this, do this integration. But here I'm just installing it because we can do the evaluation. Otherwise, as part of Hadoop admin, you need not to do anything with the Active Directory. But it's always good to install and learn because it's very easy. Since it's a Windows product, you all know. So we can do in a multiple click. But in real production, there may be a lot of huge use cases that we are not at all using those things, just using user and group informations. So once this is done, so there is an option you can see, the promote this server to domain controller. Just hit that. Then here we have three options: add a domain controller to an existing domain, add a domain controller to existing forest, add a new forest. Because this is a first time installation of AD, then we don't have any Active Directory to integrate. So domain name, you can choose any name. So I'm just using hadoop.com or whatever the domain you want to choose. Just remember, so this is the name what we are giving. You can choose any name, so it's up to you. But in our organization, they have separate domain. Then type the password. Just type some password here. Retype that password. So this is the password that is used for recovery or restoring this thing. So I'm also not 100% sure how to recover this. But anyway, in order to go next, you need to type the password, some password. Just go ahead and okay. So password is not strong. Okay, fine. Right. Then hit next. Then DNS delegation. I'm not using anything. NetBIOS thing will come here. So we'll have to wait a few seconds. Okay, so it's Hadoop. Just next. Then this is also default. Hit next. Then hit next. So here it do the prerequisites check, but you may see some warnings. And but in our case, so we can ignore that. So these warnings are okay, but we will go ahead and install. Okay, so this is in progress. So while this is getting installed, so we will go to the this server, and I use cancel. I use this reference for integrating uh, this one with the Active Directory. So before that, we need to do some prerequisites. That is, first I need to add etc host and add this machine private IP address. So what is the Windows Server private IP address? So this is the private IP, and use that ad server dot hadoop.com, then ad server. Then we should make sure, like, so we are able to ping. Uh, 170 31 31. Maybe it's restarted. We will connect again. Okay, so I think now it's starting. So once that installation is about to finish, I mean, once this is completed, that AD configuration, the server is rebooted automatically. And once this is rebooted, we can just connect again and use the same credentials. Okay, so this is the reason is just to use the administrator. We have to use that domain name, then backslash this one, and to use the password. Okay, so domain name and use the password. I think this time it should work. Oops. Administrator, and this is the password. Yeah. So now this is part of Active Directory is already installed, and under the server manager, just go to the tools. You can just hit Active Directory users and computers, and you can see the domain that we created. So under this domain, there are a lot of groups and computers, but the computer nothing is there, and users and groups are listed here. Okay, so and from here, like I said, the initial step what I did is, so I just added that in Active Directory, ATC host, so that I'm able to ping. So also I need to make sure telnet and 389. So that is a port where Active Directory is running. So I should be able to access this port. So that is also fine. Then the next, we have to install a few packages. So packages in the sense, there are set of components that we need to do. So install. Okay, install is a utility, command utility that we use for installing something. SSSD. So SSSD is the daemon that used for integrating Active Directory with the Linux. So ream, the odd job. So these are the various components or various packages that is used for integrating Active Directory with our Linux machine. So I just copied that. Okay, I'll give you this link to you guys in the chat. Okay, just bookmark this page. Okay, I just follow the same set of commands here and use. So this will install all these components. So it will take some time. Once prompted, type yes. You can see. So this is installing all the packages that we have listed. So once this is done, okay, in my case, I'm not bothered about this DNS entry. I just need to use a ream join and so ream join and user. So what is the user we are using? Administrator. And we have the password here. Okay. And what is the domain name? So adserver.hadoop.com. So this is the command that we use for joining to the AD. So what benefit we will get? So we will get the same administrator or whatever the user, like ID administrator. So administrator is the user available in Windows. So the same user we should be able to use once we join this. So I'm just typing that. So I think most probably we may need to do a reboot. So ream join administrator, then this is the host. Let me check I'm able to ping this fully qualified name. That is fine. Then telnet 389, that is also fine. Error calling start service by name for okay, so we will see this error. So some of the error I have seen, but that is something different, and I think I also got the same error. Okay, fine. So what I did is I just did a reboot last time and retried again. So ream join administrator server. Okay, so we will reconnect again and switch to root user and use the same command ream join user administrator and user equal to administrator and this. Yeah, so this error, I think it's common. So only thing, if you are getting this error, you have to reboot your system. I mean system in the sense whatever the Linux machine you are typing and you are getting this error. So once prompted for the password, so we use the administrator user, use the password, type the password here and then hit enter. So that's it. I think we can just use a ream list. Okay, so what I just use, this is the standard set of command, ream join -- user, that is administrator. So we are using the same admin user for this Windows machine to join, and this is the Active Directory server where we are going to join. So it will ask you to type the password, then type the password. Once this is done, you can just verify that this is properly done. Use ream list, so that will show the details, like so what is the username and all those details, etc. So now I'm just saying, like, so I just told, right, so this administrator will be there, but only thing is administrator at hadoop.com, so this will be there. So the reason is, so when it's trying to get the username, okay, I'm just going to create another user here. You can create new. So let's first create a group. So Hadoop admin. So group name is Hadoop admin 01. Okay. So this is the one group name. So use the global and security. That's fine. And I'm going to create another user, new user, and my name. Okay, and last name. And here login name you can just use. So based on your organization policy, sometimes they will use something like some alphanumeric or whatever it may be. Then next. So my ID is this one only, login name. Hit next, type the password. Right. So this one you can untick, just hit next and finish. So now if I come to this Unix machine, then if I type as at hadoop.com, so you can see my ID and what are the okay, so my ID alone, right? And if I add my ID to another group, so where is my ID? Okay, so this is my ID, right? And I'm just adding to, so how to add, okay, the member of, I can add another group. So just type admin, it will just not administrator, I think it's a Cloudera, sorry, not Cloudera, Hadoop, just check Hadoop admin, there is a group. I just added, apply, and okay. So now if I type ID, so ID, just user ID will list the complete details about the user. So just it takes a few minutes, and you can just verify your ID, you are member of this group. Okay, that is fine. Okay. Domain users, I think it's not reflected yet. That is fine. But if I just use this one alone, it's saying no user, but it's very difficult to type this full username. So in that case, what you can do is etc sssd.conf. Open this file and come down, use fully qualified name, just change that to false. And fallback home directory is something like the directory that it's going to create for us. So we just need /home followed by our user ID. So domain name that we don't need. So just remove that domain name part, then save it. So once this is done, just restart SSSD service. Systemctl restart SSSD. Sorry, CD. Then we will just check the status that is running. Now if I do ID, my ID alone, not with the domain name, so you can see here, but I don't know why this my group is not updated. So let me, Let me create another group. Global security, okay, test GRP, okay. Then under test GRP, I'm just adding this member, my ID, just hit OK, apply, and okay, so no problem. So let me come back here and switch to this user and to type the password. So that is the password which I have entered, right? So once you authenticate this user, like if from the root user, if you switch, this authentication won't happen. So this time it's connecting with the Active Directory, and you can see it's creating home directory. Now if you type pwd, so the home directory is created. So actually this user is from Windows, and now if we type ID, yes. So once this is after you switch to this user, now you can see the test group, and this group is also showing, right? Now if we come back to here, ID, now this is showing. Like, so in our case, it was not showing full groups until and unless we just did login here. So I just use my ID, then type the password. So this is the password that is available in ID. So if you forgot, like most of the time, if your account got locked out, or if you're 3 times incorrect password based on the password policy, then you will approach to the help desk. So what they do is, so they just open your ID, and I think account option. So unlock this. So there is a lock option, like just a unlock option is there. And also, like if you want to reset the password, that is also just option, reset the password, so that you can use that password here to log in. So any questions here? Because it's very easy. Like only thing is, so whenever we need another user, like so we can just create here, just right click, so new, and also another thing, one more thing we just wanted to show you is, like, so once we connected these Linux boxes with ID, just refresh, you can see that server here under computers, and we have the users here by default. I can create a new user, and I'm just going to create a user with Pavan, right? So there is no user ID. I'm going to create here just a new, then user Pavan, user ID is just a Pavan, and next password, use some password, and user must change, I can untick, or whatever the option I can choose, and finish. Now if I do ID Pavan, yes, I can see this Pavan is here, right? So now I just SU, or you can just open a session, I mean a new session, sorry, or duplicate a session, and you can just use this. But the problem here is in my AWS, so this password based authentication is disabled. That is the reason I'm not able to log in. Otherwise I can use the same password from this AD, right? So now if I type ID, so domain user, and if I add him to another group, I can add him member of add HadoopAdmin, just adding that, apply, then OK. Then I think this require a logout and login to sync that. Okay. So this is how we are managing the user. So every user's group, everything we are creating on the Active Directory. So Active Directory, that this is very simple. Just open the server manager from here, Active Directory, users and computers, and you can create the users and organization unit. So this is our domain. Under this domain, so we have this option. And also we will be integrating all the Unix boxes in our cluster with this Active Directory and use that. And also we can integrate Cloudera Manager with Active Directory, and whatever the various components in Hadoop, we can integrate with the AD. So any questions here?
Sujesh, have you got any documentation which we can use to do it, like where you go the link, etc. So
This
or
one,
we can follow this video. Yeah.
I don't have a one, but I'm in the process of preparing that everything.
All
Okay,
right. Okay.
maybe it takes
Okay.
some time for me to do all those things, but I'll try my best to do that. Okay, I'll share you because I'm just trying to prepare that.
And one more question. So take example that when we are preparing this AD server, take example if I prepare it for myself and I'll shut down by when I'm finishing it, and after 2-3 days when I start back the server again from AWS, I will have my installation there, isn't it?
Sorry, can you explain that again? Because I lost in between.
So, sorry. Okay. Take
Yeah.
example on AWS when I host this server, the way you have done it,
Okay.
and when I stop the machine,
Mm.
yeah.
Mm.
Take example after 2 days, if I start the machine again, yeah, I will
Mm.
have my AD installation there, or it is not gonna kill.
Yeah, it will be there. So it's not going to make anything. Just we are just shutting down the VM. Whatever the contents in that VM will be there exactly after 1 week or 2 weeks or wherever you are keeping.
Right. Okay, that's fine. Yeah, fine.
So it will not make any changes at the operating system level. So any other question? I think it's a very easy, but so because I think most of the people, some people maybe already know this part, but the people who are not at all tried this, because some people because for HadoopAdmin to get access to this AD and all very difficult, so they will give very limited access to this AD. So some one username we will give, and whatever the parameters we need, they will AD team will give. We just make use of that and do that. But other than that, go in depth, so we won't get. But here we can use that this option. But again, it's not a in detail Active Directory demonstration, but there are a lot of things available. It's Active Directory itself a very huge topic like Hadoop administration. So we are just making use of one small portion of this. So any questions, comments, anything? So if everyone is good, then we will wind up for now, and we will continue tomorrow. And one more thing is this at the same time is okay for you guys?
I think 11 o'clock is better from my point of view, if you can do that. Well, sorry, the same time which we are doing. 11 is my time, but it's your time is like what, 4:30, isn't it?
Okay. We will check that and we'll sort it out. Okay, no problem. Yeah. Okay. So thanks for your time. So we will continue tomorrow.
Thank you.
Yeah. Bye.